Hi dear students, welcome to the last section or the last topic from the electric field and electric charge. The last video we have completed the theory part, and today we are going to see the different types of problems. We will touch different areas of the chapters we can touch it upon, and based on that we will do few questions of the different concepts are involved. So we will move to the classroom discussion questions here, and we have a set of 45 questions are there in total. We will do one by one. Okay, so let's move with we will start with our first question. So classroom discussions questions, we are discussing different questions based on the theory whatever we have learned till today. Okay, so we'll start question number 1. Okay, the surface charge density of a thin charged disk of radius r is sigma. The value of electric field at the center of the disk is sigma divided by 2 epsilon 0. With respect to the field at the center, electric field along the axis at a distance r from the center of the disk reduces by. So the question is related to disk, and we know the formula which is related to electric field intensity due to a disk. Before going to the formula, I forgot to mention one thing. Now we have learned about different theoretical concepts, right? From first day till the last video, we have learned lots of formulas will be there. So each of every sessions, if I come up, then definitely it will be end up with some set of derivation and some set of formula. What you have to do means you have to maintain one separate notebook. Okay, that notebook you have to name it as formula book. This normally we will do it in Brainiacs. So we will name here it is as a formula book. So you have to maintain one formula book. Now theory topic is over. What you have to do means you have to write the chapter heading, then each of your topic, for example, electric field intensity due to a dipole along the axis, along the equatorial point, at any point. So we have learned different formulas. So just to write a bullet point, for example, electric field intensity at the axis of a dipole is equal to k into 2p by x cube. So similarly, you can write various formula we have learned under each of this topic. Okay, so that if you are doing some questions now also, in future also, if you are not remembering, because we all are human beings, we will not remember every formulas. In case if you forget, as a quick revisions you can go through this one. And then another advantages of this one means just 1 or 2 days before the examinations also you can refer these parts. So that is quite important to maintain a formula book. Now itself you can start, so that it is easy. We cannot do it on later time after completing all the chapters. Now it is one by one it is going, so you can do it now itself. So without wasting the time, let's move to the first question. Okay, so what is given here? Question is talking about a disk. We need to find out electric field intensity due to a disk. So question number 1. Electric field intensity due to a disk is equal to sigma by 2 epsilon 0 1 minus x divided by root of r square plus x square. This is the formula we know. Next, electric field at the center is given. Center means x equal to 0. So E at the center is given. When x is equal to 0, what will come? Sigma divided by 2 epsilon 0. X is the distance. In case of a disk, if x distance away, then the electric field here, this is given as this formula. Now here we don't have a disk a disk at a distance of x meter away. Center means x will be equal to 0. What is the speciality? X will be equal to 0 at the center. Question is asking, that is already given, sigma by 2 epsilon 0 is given in the question, and with respect to the field at the center, electric field along the axis at a distance of r meter away. Now question is asking at a distance of r what will happen. So what is the formula? E at a distance of r will be equal to sigma divided by 2 epsilon 0 1 minus r divided by root of r square plus r square. What will come? 2 r square. So if you simplify this one, sigma divided by 2 epsilon 0, r and r will get cancels. 1 divided by 1 by root 2 is the formula we got it. Okay, next what we will going to do, electric field at the center and electric field at a distance of r meter away. Question is asking about the percentage, okay, field along the axis at a distance r from the center of the disk reduces by. So center of the disk sigma by epsilon 0 is the highest. So 1 by sigma by epsilon 2 epsilon 0 will be here, and that is minus how much will be coming, 1 divided by root 2. Okay, now if you compare these two formulas, at the center how much it is there, sigma by 2 epsilon 0. At a distance of r, how much will be there, sigma by, if you split this one, sigma divided by 2 epsilon 0 minus extra 1 by root 2 into sigma divided by 2 epsilon 0. So comparable to center, this formula is reduced by how much? This is the reduction factor. Correct, this is a reduction factor. So already sigma by 2 epsilon 0 at the center, with respect to center, this is center value. From the center, this is reduced this much. How much it is reduced? Sigma by 2 epsilon 0, if you take it outside, how much it is reduced? 1 minus 1 by 1, this is the original value, 1 by root 2 times it is reduced. 1 by root 2. 1 by root 2 means what? 1 divided by root 2. If you need to convert into percentage, means what we have to do? We have to multiply it with 100. So 1 by root 2 times it is reduced. 1 by root 2 means 1 by root 2. 1.414 into 100. This is 0.707 into 100, which means what? 70.7 percentage. So it is reduced by 70.7 percentage. It is there in option A. So option A is the right answer for the question number 1. Hope you understood, right? So that's what I'm telling. If you're hearing the word called disk, then this formula has to come to our mind. Without that, we cannot proceed all these steps. That's what I strongly recommended you to maintain the formula book, because formula book is quite important to answer such kind of questions, because in physics sum or numerical based questions are majority are based on the formula. So formula you have to remember, for that you have to maintain the formula book. Let's go to the next question, question number 2. Okay, so question number 2, second question. Solid conducting sphere of radius A has a net charge positive 2q. So some diagrams are given on the right side of the question. I am just drawing the diagram. I'll keep it like this, A, and we have another line along this line. So this radius is A, and this radius is B is given, and this radius is C is given. A solid conducting sphere of radius A has a net positive. So this will have a net positive charge of plus 2q, that is given in the question. A conducting spherical shell means inner is empty, inner radius is B and outer radius is C respectively. It is given, it's well understood. Okay, B and outer radius is C, concentrics with the solid sphere, and has a net charges of minus q will be there. So this will have, this solid conducting sphere will have a charges of minus q, which means here this conducting wire will have a charge of minus q. The surface charge density of the inner and outer surface of the spherical shell. So we need to find out the surface charge density here. This is, I am giving sigma 1. We need to find out surface charge density here called sigma 2, inner and outer shell. This was the question. Surface charge density basic formula is what? Surface charge density means charge per area. Many times I told while I am taking the theory itself. Charge per area. Here one important concept will be there. Listen here. Plus 2q will be here on this A circle. Okay. And then what will happen? We have learned in the first video itself, we have learned two concepts. Charging by conduction, charging by induction. So conduction means whenever there is a contact, charge will transfer from one body to another. Whenever there is no contact, charges will be still can induces on the other body, which means here plus 2q will be here. Here on this surface what will come? Opposite charge minus 2q will come. Okay, this minus 2q will induce, the other end what will induce? Plus 2q, just opposite. Here plus means minus, here minus means here plus will induce us. So with respect to the inner surface whose radius will be equal to what? C. So sigma 1 will be equal to charge per area. What is the charge on the inner circle? Minus 2q divided by area of this one is 4 pi r square. R means what? C square. And sigma 2 total charge. Here plus 2q is induced, but already what is the existing charge will be there? Minus q. So what is the total charge? Plus 2q plus minus q. Minus q is already there, it is given in the question. And due to charging by induction, the plus 2q is come here extra. So plus 2q plus minus q divided by what is the area of this one? No, this area inner circle is radius 4 pi b square. For outer one 4 pi c square. Okay, inner one b ആണ് radius, outer one radius c ആണ്. So this has no change. This we can simplify. So this become q divided by 4 pi c square. This is the answer, sigma 1 and sigma 2. So minus 2q divided by 4 pi b square and q divided by 4 pi c square. This is matching with your option number A in the second question. Okay, so the only concept you have to remember again, sigma, here two concepts will be there. One is a formula of sigma, charge divided by area, that you have to remember, point number 1. Point number 2 means charging by induction property will be there. Here plus 2q, then minus 2q will induce here. Here it is minus 2q, then plus 2q will induce here. And this will go from inner side to outer side. Then we will see what is the total charge here. If the question is asking what is the surface charge density on the circle A, then what you will say? 2q divided by 4 pi a square. For B has total charge how much? Minus 2q. So minus 2q divided by 4 pi b square. Next we'll go to C. See what is the charge? Charging by induction give plus 2q. Already I put a charge called minus q. So plus 2q with minus 2q, q divided by 4 pi c square. For all this kind of model of question, you always start from the center and you will go next level. Okay, so charging by induction plus surface charge density is the concept behind this question. We'll move to the next question. Third question. Two equally charged identical metal spheres A and B are repel each other with a force called F. So I read the question, I just make it as a diagram. Two equally charged A and B separated by a distance metal sphere repel each other with a force called F. So the force between these two bodies is called F, clear. The spheres are kept a fixed distance r between them. So the distance between them is how much? It is called r. A third identical charge but uncharged sphere is brought in contact with A. Now this is Q charge, this is Q charge, two bodies A and B. Now a third charge is coming which is in contact with the body called A, and so what will happen? The charging two bodies, one charge is called Q, another body A will be here and C will be here. C has no charge. When two bodies are in getting contact, charge sharing will happen. After disconnecting these two, A body and C body, what's the charge? Q by 2 and Q by 2. Now the charge of A is Q by 2, B is still Q, and another charge I am placing here, and this charge will have a charges of Q by 2. This is the body called C. Okay, and then placed at the midpoint of the line joining of A and B. I placed at the midpoint. Magnitude of net electric force on C. C net force. We have to find out the net force. Okay, so net force on Q means the force due to this charge. Okay, so this both are positive, so it's a repulsive force. This body will move like this one, F1 force, and Q2 and Q both are positive, will not attract. This will move like this one. So two force will be there, F1 force and F2 force. Question is asking about the magnitude of the net electric force on C. Total force we have to see. So both the forces are in opposite direction. So to find out the net force, two vectors are acting in opposite direction means what we will do? We will subtract. q by 2 equal sign, so this will not attract, this will move away, so that force is F1. Q by 2 and q will not attract, so q2 will move backward because of repulsion. So we will find both F1 and F2. So F1 will be equal to first force K into q square by 4, q1 q2, q by 2 that is F1 divided by distance between them, which is what, r by 2 the whole square, r square by 4. Okay, so 4 and 4 will get cancelled, so it become k q square by r square. Let's find out F2 also. F2 is given k into q by 2 into q by 2. So q square by 2 divided by distance between them, r square divided by 4. Central, it is placed at the center, so half of the distance. So this will become what, 2 into k q square by r square. So by comparing F1 and F2, which one will be higher? F2 is higher than F1. So to find out total force, higher force minus lower force, F2 minus of F1. F2 is what? 2kq square by R1. This means what? Kq square by R1. So if you are subtracting F2 minus F1, what you will get? Kq square divided by R square, you will get it. Kq square divided by R square. Okay, this is the total force on the body number C. So I can say F net is equal to Fc. Now we look into the question. Two equally charged identical metal plate spheres A and B repel each other with a force of F. So first, if A and B will be here, if A and B will be here, what is the force between A and B? K into q square by r square. Now the attractive force between the two body FAB is given in the question as F. Whatever we are getting for the net force on the charge C, that is called Fc, this is also equal to F. So our question to the answer is option number A. A means what? Total force will be equal to the net force on the body. So which is matches with option number A. Option number A, right? Let me look. Option A. F 3 by 4, F by 2, F by 4. So F is answer. Option number A. Fc will be equal to F. We'll move to the next question. Question number 4. In the figure, diagram is given. Net electric flux through the area A is given by phi equal to E dot A. This is which law? Gauss's law. When system is in air medium. On immersing the system in water, electric flux through the area. So flux in air is given E dot A. What is the general equation of electric field? 1 by 4 pi epsilon 0 q by r square into area. Epsilon 0, this I have told, relative permittivity of a medium while I am taking Coulomb's law, right? So this is for an air medium. Okay, so flux in air. Now flux, it is immersed in some liquid. So flux in a liquid medium is equal to 1 by 4 pi epsilon m permittivity of a medium q by r square into A. All other factors are not changing. Medium is changed means this will change. I told epsilon m divided by epsilon 0 is called epsilon r. In our third or fourth some video we have done this part. Epsilon m divided by epsilon 0 is equal to epsilon r. Ideally, in normal case, epsilon r value is greater than 1. If you are doing like this one, I can say epsilon m will be equal to epsilon 0 into epsilon r. Normal case, epsilon m greater than epsilon 0. If epsilon m is greater means this is greater. If this is greater means what will happen? Flux will be reducing. So comparable to epsilon 0, epsilon m is higher. If it is higher means flux in the liquid will be getting reduces. So which will be reduces means decreases. So this means which is matching with your option number D. Option D is the right answer for the fourth question. Let's move to the next one. Okay. The fifth one. the fifth question. ABC is an equilateral triangle. Charges plus Q are placed at each of the corners as shown in the diagram. Electric field intensity at the center O will be what? We will see the diagram. We will draw the diagram for our purposes. So we have an A will be here, B will be here, and C will be here. And we have at the centroid point at O point will be there, which is at a distance of R meter away from each of the corners. We have placed plus Q, we have placed plus Q, we have placed plus Q. All charges are placed will be here. What is the electric field intensity here? This was the question. So while looking into this one, electric field intensity I am going to find out at this point. Listen very carefully. Electric field, let me take another color for better understanding. So electric field intensity plus Q charges, electric fields are intensity are away from the charges. So electric field intensity due to plus Q is like this. So this I have one electric field, and the electric field due to the charge at C is electric field lines are going away. So the electric field is like this. This is also E, because all are at same distance, all are at the same distance and same magnitude of charge. So the E value of this value equal to this value. Here also charge will be there. So electric fields are not coming inside, electric fields are always going outside. So this is electric field E. Okay. This is like a kind of a fan leaf, right? So each of the fan leaf angle is what? 120 degree, 120 degree, and this is 120 degree. Here I keep this vector here. I need to find out the total electric field at this point. So I am going to find out the electric field intensity between these two vectors. I am going to find out. So what is the formula? Resultant. This is R, root of A square plus B square, right? So which means I am writing E square plus 2A1A2. So AB, or A square plus B square plus 2AB cos theta. So what is cos theta? What is the angle between them? Cos 120 degree. So which become what? 2E square plus 2E square into cos 120 is minus 1 by 2. So this will be cancelled. So 2 and 2 will be cancelled. So 2E square minus E square is E square, which is equal to E. So which means resultant will be equal to E. Now if you look into this diagram, one electric fields are going upward, another electric fields are going downward. What is the total electric field? The resultant electric field will be equal to E minus E, which is equal to what? 0. There are two electric fields are vector quantity. One is directing upward, another one is directing downward. So upward resultant is equal to E, and downward is already E will be there. So total electric field will be equal to 0. So we find the resultant of these two. This is acting like this, and already one will be there. Here I don't want to find resultant. This is one way. If some student is doing, okay, this is I taken as one vector. So then you have to find the resultant between these two. In that case also, this field will be like this. So any two you can consider, other one you can leave it out and you can find the resultant. So the total electric field intensity at that point will be equal to 0. So this is matching with your option number D. Option D is the right answer for question number 5th one. Okay. Let's move to the question number 6th one. Question number 6. What is question number 6 is speaking? An electric dipole is placed in a uniform electric field. This we have learned, right? And an electric dipole is placed in a uniform electric field. The dipole will experience us, which is a matches with these options. First one, force that will displace us, no. If a dipole is placed in a uniform electric field, it will never experience a force. If a dipole is placed in a non-uniform electric field, it may experience a force. So here there is no chance of force. So first option is wrong. Second option, a force that will displace us, no force. So B is also wrong. Third one, C, a torque which will rotate it without a displacement. When a displacement will come, when something is moving, in order to move linearly, linear motion required a force. So without a displacement indicate there is no force, but there is a torque. So that is the answer. Answer to the question is option number C. Option C is the right answer. In a uniform electric field, torque is not equal to 0 ideally, but force is equal to 0. Torque, I cannot say this is may or may not. Okay, I have to say depends upon the angle, but force is always equal to 0. There is no displacement. Torque which will rotate and force it will no. Fourth option, D option is what I have read now. So no chances of force at all. So here answer is equal to option number C. Let's move to the next one. Seventh question. A uniform electric field E exists along a positive x-axis. The work done in moving the charge. Okay. Charge is given. Let's write some quantity. 0.5 coulomb is given through a distance. So some distance x will be given along the x-axis 2 meter along the directions, making an angle theta equal to 60 degree with x-axis. So the work will be equal to 10 joule, magnitude of electric field. So what is work? General formula. Work will be equal to F dot S. This we are normally learn it in our work power energy chapter, right? Work into displacement. In a school also we are learning the same story. So what is F dot S? F is cos theta, angle between force and displacement. If you look will be here, what is 60 degrees given? Along the direction a force, the work done in moving the charge 0.5 coulomb through a distance 2 meter along the direction, making an angle, which means this force with respect to the direction of displacement making an angle equal to 60 degree. So that is given there. So now we'll substitute. What is work? Force. Force will be equal to QE, electrostatic force, into displacement into cos theta. All the factors are given. We can substitute. Work will be equal to 10 joule. I am not writing the unit. Anyway, we need the magnitude 10 joule. Q is 0.5 into electric field is, no, it's not given. We have to find it out. Displacement is 2 meter and cos of 60 degree. So cos of 60 degree. So 10 equal to 1 by 2 into E into 2 into 1 by 2. So this 2 and 2 cancel. 10 is equal to E by 2 and E is equal to 20. E is equal to 20. What is the unit of this one? Electric field. F is equal to, F will be equal to QE, right? QE. So Q equal to F by Q. F in the unit Newton. So it is Newton per coulomb. Newton per coulomb is the right answer for this question. Newton per coulomb is one of the unit, but it is not given, will be there. And answer is 20. So another unit, this you will learn it in potential also. There is one formula. You don't want to remember it now. E is equal to V by T. E is equal to V by T. V means voltage divided by meter, volt per meter. This is the another formula of electric field. This is related with the potential. This we will learn it while we are going to the next topic of capacitance chapters. But here, that's what the instead of unit Newton per coulomb, volt per meter is written in the question. So answer D is the right answer for question number 7. Answer is D. Okay. Question number 8. Which one of the following graph represent the variation of electric field with the distance r from the center of a charged spherical conductor? Spherical means conductor. I told spherical conductor, hollow conductor, solid conductor, all are same group. Inside it is empty, kali, nothing will be there. Only for solid non-conducting sphere, inside it is filled with charges. So inside no charges. So in case of a spherical conductor, which of the following graph will be represent? As no conductor, inside it is empty. This is a 1. So inside it is empty. Only charges are present at outside. So what is the graph of this one? Inside it is empty. Charges are present at the surface. Then it is decreases. So E is proportional to 1 by r square. E in will be equal to 0. So in question number 8, electric field intensity of a spherical conductor. Spherical conductor means inside it is empty, outside charges are present. So electric field intensity at inside is available. It is not available. Electric field intensity will be equal to 0 E with respect to R, and electric fields intensities are available only at the outside surfaces. So this is a graphical representation. If the same question is asking electric field intensity for a solid non-conducting sphere, what will happen? Solid non-conducting sphere means your graph will be look like this one, E with respect to R. Solid non-conducting sphere means charges are present everywhere. Last class I told, right? In this case, charges are present only at the surface. Charges are not present anywhere. So here E is proportional to R and E is proportional to 1 by R square. If it is solid non-conducting, then this will be the answer. In that cases, option B will come, but in this question, answer is option number C. This is for a spherical conductor. Or it can say solid conductor. Last class I told, right? Solid conductor. Or this can also say hollow conductor. So many options will be there. Spherical conductor, hollow conductor, and yeah, solid conductor, all this case. This is for solid non-conductor. So see the questions and depends upon that, take the appropriate options out of this one. What is matches with this question expectations. Okay. Okay. So let's move to question number 9th one. So the 9th question. A hollow cylinder has a charge Q, coulomb is within it. A cylinder is given. Okay, normal pipe like structures. If phi is a hollow means inside it is empty, it is just a cylinder. Okay, if phi is the electric flux in units of voltmeter associated with the curved surfaces B. Okay, so I can say total flux phi net will be equal to Q divided by epsilon 0. Total flux means there are surface will be there A, B, C. So flux surface number A plus surface number B plus surface number C, all together it is Q by epsilon 0. Surface number, the flux associated, unit of voltmeter associated with the curved surface is B. Curved surface B is given as flux number C. And the flux, we need to find out the flux linked with the plane surface A in units of voltmeter. Okay, this is what is given. So let me read the question once again. A hollow cylinder has a charge Q coulomb within it if phi is electric flux in units of voltmeter associated with the curved surface B. Okay, B is the curved surface. A and C are same, right? A and C are same. So I just take it as flux dash, and here also I am taking it as flux dash because A and C are symmetrical, circular structure, which is equal to Q divided by epsilon 0. Okay, now I'll go to the question again. Flux linked with the plane surface A. Flux linked with the plane surface A. So, A means phi dash. So, we need to find out phi dash. So, 2 phi dash plus phi equal to Q by epsilon 0. So, phi dash equal to Q by epsilon 0 minus phi whole divided by 1 by 2. So this is a flux associated with the surface number A, or this is also equal to the flux associated with the surface number C, because both are identical, and we got this answer. Q by epsilon 0 minus phi whole divided by 2. This is matches with your option number D. Your option D is the right answer for the 9th question. Okay, let's move to the 10th question. If EA be the electric field strength of a short dipole at a point on the axis, and EE be the equatorial lines at the same distance. So with respect to a dipole, EA be the axial electric field. What is the formula? K into 2p divided by x cube. So we have minus q and plus q dipole will be here at a distance of x from the center. This is a formula. And with respect to equatorial, it is what's the formula? Kp by x cube. So minus q charge and plus q charge, we are finding electric field will be here. And this electric field is given this one. What's the direction of this electric field? Along this direction. What's the direction of this electric field? Like this. Here the minus, it is plus. So dipole moment is in this direction. Electric field is like this. I told the angle between electric field and dipole moment in the previous videos. It is 180 degree. Here angle between electric field and dipole moment. Both are directing in the same direction and it's making an angle of theta. So E and P theta equal to 0 degree. Here E and P theta equal to 180 degrees given. So I can say axial electric field equal to 2 times of E equatorial electric field. So this is matches with your option number B. Option B is right answer for question number 10. Let's move to the next question, question number 11. The positive charge of equal value Q are placed at the vertices of an equilateral triangle. So Q will be here, Q will be here, Q will be here. This is an equilateral triangle. All sides are equal. Resulting lines of force should be sketched as in. So which of the following is a correct statement? That's what. So here we need to know the properties of electric field lines. What are the properties of electric field lines? Electric field lines will never cross each other. Electric field lines will never form a closed path. So there are a lot of rules will be there. So based on the rule, we'll see number 1, first option. It is like a seed like structures, right? And the lines are also get closed. So that will never become an answer. Second option, electric field lines are always emerges from positive charges. Always emerges means this all are positive charge in the question. So the electric field lines are always emerges from positive charge. Always emerges from positive charge like this. So this will always emerges from positive charges. So like this. Starting from here, 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 never cross. So it should go like this. Starting from here, starting from here. This is the lines of force. And if you look into option number B, this is more or less similar, but if you see, it is some of the lines, it is not touched on the charges. It should touch on the charges. It should touch on the charges. So B is not touched on the charges, so it is not the correct answer. If you look into C, perfectly matches with them. So answer is option number C is right answer for this question. If you look into option number D, again it is a circle closed path that will never comes as an answer. So option C is right answer for question number 11. Move to the next question, question number 12. Question number 12. What is question number 12 is specifying? 3 point charges Q1, Q2, Q3 in the order are placed along a straight line. Q2 and Q3 are in equal magnitude but opposite sign. If the net force on Q3 is 0, the value of Q1, Q2, Q3 are placed on order equally placed. So let place Q1 and Q2 and Q3 are equally placed. So I take the distance as a meter or x meter, whatever. So but one condition is given. Q2 and Q3 are equal in magnitude but opposite sign. So I can say Q2 is equal to Q3. Okay, Q2 is equal to minus Q3. If Q2 is plus Q, then this become minus Q. That is the understanding. Okay, both are equal magnitude but opposite sign. So I replace the diagram like this one. Q1, Q2 I am giving positive sign and Q3 I am giving negative sign. Distance is still same, a meter. What's the question is asking? The net force on Q3 is 0. Value of Q1. Net force on Q3 is, this is our Q3. So net force on Q3, we'll see what all the forces are acting on this Q3. Okay. Because of the first charge, this is a near charge. This body will attract towards this one. Okay, what will happen to this one? This is a Q1 charge. We don't know whether it is positive, whether it is negative, I don't know. So to have a net force, definitely you have to remember, to have a net force on this charge equal to 0, already one force will be here. So to have a net force on that charge is 0 means other forces is acting in this direction or in the opposite direction. Already one force, this is given in the question, these two, this Q2 and this Q3 are equal in magnitude and opposite sign. Based on that, definitely this minus Q will attract towards this one. It's very clear, we can't do anything over there. But here Q1, we don't know whether it is positive, whether it is negative, it is not there. It's not given in the question, positive or negative, nothing is given. But if Q1 is positive, what will happen? Minus Q will come again in this direction. So total force, two bodies are pulling like this means the total force will never equal to 0, right? Because one guy is pulling, other guy is also pulling. So it is not 0. It's not possible. So what will happen? This should be a negative charge. If this will be a negative charge, then this negative charge will repel. So definitely the other forces should be in the opposite direction. Two forces are equal means total force will be equal to 0. So the body in equilibrium state. Okay, total force equal to 0 is a condition which is given there. So we are make use of that condition. So first we will find this force. What is this force? K into we know one force in this direction, Q into Q. So Q square divided by A square. This if you are multiplying with the plus Q and minus Q, you will get minus Q will be here. Okay, so that minus is representing in this direction, that's all. Okay, or in another way I can say total force acting on the body. Okay, so not to confuse you, I am writing total force on Q3 equal to 0. So total force equal to Q3 is equal to 0 means body is in equilibrium or not moving. So we'll see the force due to this first one, these two. What will come? K into Q square by A square. What is the sign? Q into minus Q. So it's negative charge. Plus, what's the charge between them? Q1 into minus Q divided by, what's the distance between them? A plus A. So it is 2A, it become 4A square. So K will be here. Okay. So K will be here. So total force will be equal to 0. So K A square. Here also K A square will go. We'll cancel it out. So that is equal to 0. So now I'll come one step back to here, and here I have minus, so minus Q square, that's all. K and A square is already cancels, plus the other side is Q1 into what is there? Q1 into minus Q. Q1 into minus Q whole divided by 4 equal to 0. I am taking one to the right side. So Q square will get cancelled. So here we have minus Q. This is taken to the right side. So it becomes Q1 divided by 4. So what you are getting for Q1? Q1 will be equal to 4 times of Q, you will get it. Okay. So Q1 you will get it 4 times of Q1. 4 times of Q. Next, here Q1 they are asking in terms of what is called Q3. So what we have considered? Q3, okay, Q2 is equal to plus Q. So Q3 equal to what we have considered? Minus Q. Okay, so minus Q means here I can say this charge means what? Q1. So Q1 equal to 4 times of Q means what? Q means I can substitute Q2 or I can substitute it as minus Q3. Correct? Okay, minus Q3 is minus Q. Listen, minus Q3 is minus Q. So plus, so minus Q3 is minus Q. So plus Q3 means what? Plus Q. So I can simply written as this is called Q3. Okay, I assumed Q2 is equal to Q. So Q2 is equal to minus Q. Minus Q is equal to minus Q3 is equal to minus Q. So plus Q3 is equal to plus Q. So 4Q. Q means 4 into Q3. This is matches with your option number A. So first option A is a right answer for this question. So total, if total force on the body is equal to 0 means this is our body called Q3, this is our body called Q2, this is our body called Q1. So Q3 total force we are calculating. Force due to Q2 we have written. Force due to Q1 we have written. All forces we are adding and equating to 0. That is a condition given in the question. we as a person, we obeyed that condition and we applied and we got the final answer as option number A. So 12 questions we have discussed, further also we have to continue. Last we have discussed it till question number 12 and we are continuing from question number 13. Okay, so let me read the question along with me. You can also read the questions and yeah, we'll do it together. Electric charge uniformly distributed along a long straight wire. 13th question. Okay, long straight wire of radius 1 millimeter. Charge per centimeter length of the wire is q coulomb. Another cylindrical surface of radius 50 centimeter and the length is 1 meter is symmetrically encloses the wire. The total electric flux passing through the cylindrical surface will be. What is given? We have a wire and this wire is enclosed by a cylindrical surface. What is the length of the cylinder? Length of the cylinder is given as 1 meter. So for radius will be given for both of this one. We need to find out the flux. Flux will be equal to what? Closed integral E dot A, which is equal to Q enclosed divided by epsilon 0. That's a concept. Okay. So for 1 centimeter q coulomb. So in 1 meter, how many centimeters will be there? 100 centimeters is equal to 1 meter, right? So here there are 100 pieces will be there. Here there are 100 pieces will be there. So 1 to 100. So for 1 centimeter, what is the charge? Q. So for 100 centimeter, what is the charge? Total charge 100 Q. Okay. So the total flux will be equal to, what is the charge enclosed will be here? It is 100 Q divided by epsilon 0. That's the answer, which is matches with option B in the given question. So answer is option B for 13th question. We'll move to the next question. Question number 14th. Okay. 14th question. A small sphere carrying a charge Q is hanging between the two parallel plates by a string of length L. Time period of the pendulum is T0 when the parallel plates are charged. Time period changes to capital T. The ratio of T by T0 is equal to. This was the question is given. Okay. So what is initially they have given? We have a plates and these plates will have positive charges. Initially no charges. Okay. But in the given diagram it's given like this. And a charge which is hanging like this one. Okay. So what will happen? The charge is hanging in between the two parallel plates by a string of length L meter. So whose length is L meter. And time period of the pendulum is T. So before the plate is charging, the time period is T0 is equal to T0 equal to 2 pi into root of L by G. This you have learned in oscillation chapter from 11th. Hope you remember this one. At least now also you can remember and note down. The period of oscillation is 2 pi root of L by G. The second part of the question is speaking about what? Time period of the pendulum is T0, whatever given here. When parallel plates are charged. When parallel plates are charged means what will happen? An electric field will be generated. A force will be there in this directions. Okay. An electric field will be there. So electric field will give rise to a force. So F will be equal to QE. One electrical force will be here. Okay. So in this case, F is equal to ma accelerations and which is equal to QE, and acceleration is equal to QE divided by m. An additional acceleration when the body is just hanging, if the plate is not charged, in this case what is acceleration? G. Now what will happen when the plate is charged? That's the second part of the question. When the plate is charged, an additional acceleration, already G will be here, plus extra A is also coming, and this A is given due to this A is coming due to this additional electric field which is available on the plate. So what will be the formula? So T is or T dashes will be given. It is given just a T. So T will be equal to 2 pi into root of L divided by G plus A. So which means what? 2 pi into root of L divided by G plus A. G plus QE divided by M. Now, question is asking about what? What is the ratio of t by t0? What's the ratio of t by t0? How to find out t divided by t0? You have to divide this with the another one. 2 pi will be getting cancels, of course. So, we will write root of L divided by g plus qe divided by m whole divided by root of L divided by g. Root L will get cancels each other. So finally root g will go to numerator, root of g divided by g plus qe divided by m. This is the right answer. Which one is coming from the options? G divided by root g divided by g plus qe divided by m raised to 1 by 2. There are options will be there. You can see 3 by 2, 5 by 2, but answer is 1 by 2. Answer is matches with option C is the right answer for question number 14th. Okay, hope it is clear for you. We'll move to the next question. The next question is speaking about 15th. Some values or some parameters are given in the question. 15th question. Question number 15. An electric dipole consisting of two opposite charges and charge will be given. So immediately we will write the charge. 2 into 10 power minus 6 coulomb is given. Are separated by a distance. So distance from here to here. 2 charge minus q and plus q. Separated by a distance. 2d value is given. The separated distance 2d value is given. Separated by a distance of 3 centimeter. 3 into 10 power minus 2 meter. We have to convert everything into meter SI system. Is placed in an electric field. E is also given. E is how much? 2 into 10 power of 5 Newton per coulomb. Unit is also given. Torque experienced by. Torque is equal to what? P cross E. Okay, P cross E, and which is called PE sin theta. Theta is not given. Theta is not given. If theta is not given in the question, if they are specifying something extra, means if theta value is given in the question, we have to take it as. Else this factor you can consider to be 1. So what's the formula? Just PE. PE means what? Q into 2D. Correct? We have learned this on the theory sessions. Dipole moment. Charge into distance between the dipole into electric field. What is Q? Is given. So 2 into 10 power minus 6. 2D is also given. 3 into 10 power minus 2. Electric field is given here. 2 into 10 power 5. Correct? All the quantities 10 power 5, 10 power minus 6 and 3 into 10 power minus 2. So 2, 3, 6, 6 into 2, 12. 12 into, this is 10 power minus 6, 10 power minus 2, 10 power minus 8 and 10 power minus 3. So 12 into 10 power minus 3. This is something is coming. 12 into 10 power minus 3 Newton meter. So unit of torque is force into torque. Force into perpendicular distance. Force is Newton and distance is meter. That's why its unit is Newton meter. Answer is option C. Hope this step is clear. This is a direct questions to the direct formula. No complications, nothing. Very straightforward question. Okay. Move to the next one. Sixteenth question. Electric field in a certain region is acting radially outward and is given by. Electric field is given. So whatever is given, we will immediately write AR. A charge contained in a sphere of radius A. A charge contained in a sphere of radius A is centered at the origin of the field. Okay, so this is giving an electric field which a value is equal to E is equal to AR. An electric charge is placed at the center of a sphere and which is giving an electric field with this formula. Okay, centered at the origin will be given by. A charge is contained in a sphere of radius. We need to find out charge. Okay, charge means what? So flux will be equal to closed integral E dot A, which is equal to Q enclosed by epsilon 0. So charge is enclosed within the Gaussian surfaces. So Q enclosed will be equal to, if I am considering, because electric field will be given, so I am taking this formula. So closed integral E dot A, this is one factor and which has to be multiplied with epsilon 0. What is the E value? E value is equal to AR. R is what? Radius A. And closed integral of A. cos theta will be there. E dot A means what is called cos theta. What is theta? Electric fields are going like this, area vector is like this. So angle between electric field and area vector, theta equal to 0 degrees. So cos 0 is 1. Okay, so I am directly writing cos 0 will be here, and this is whole multiplied with epsilon 0. Okay, so AA, what is the area of a sphere? 4 pi r square. 4 pi r square. What is r? R is the radius. So a square, cos 0 is 1 into epsilon 0. So answer is 4 pi capital A epsilon 0 into small a cube. This will becomes as the answer. 4 pi epsilon 0 a cube. Answer is option B. In the given option, answer is option B. Okay, straightforward question. Electric field is given, R will be equal to A substituted, and we are integrating A. A means for a sphere, it is 4 pi R square, R become A. We are finding the Q enclosed charge they are asking in the question. Okay, fine, perfectly. So we'll move to the next question, question number 17th. Question number 17th. 17th question. 17th question is speaking about what? The spatial distribution of electric field due to charge A and B is shown in the figure. Which of the following statement is correct? If you look into this diagram, you can see 2 points will be here. A and B will be here, right? A is the left side, it is missed to, yeah, it's there in the diagram, but it's along with the options. So if you see that diagram, you can see A and B, 2 points will be there, and electric field intensity is higher, means what? A charge is producing the electric field intensity, right? When electric field intensity is very stronger, means charge is very stronger. So here, if you consider that point number A, the point A and the point B. Point A, how many lines will be there? At least how many lines are going out? Left side, 3 lines are going out. Right side also 3 lines are going out. So number of lines are coming from A is very high comparable to that of B. For B, 2 lines are coming. For A, 3 lines are going out. So A will be higher than B. And if a line is going out, means what it indicate? It is indicate it's a positive charge. If an electric field lines are coming inside, what it is indicate? If it is coming inside, means it is negative charge. If it is going outside, means it's positive charge. This is what we have learned when we learned about the properties of electric field lines. Electric field lines are emerges out for positive charges and coming into that system when it is a negative charges. So based on this one, we know A is a positive charge and B is a negative charge. Okay, so A is positive and B is negative, and modulus of A is greater than modulus of B, which means that what? The charge at A is higher than charge at B, because number of electric field lines at the point A is higher than number of electric field at the point number B. That's what option A is the right answer for the 17th question. It's just a diagram is given and you just need to analyze the diagram. That's all. Nothing complex, nothing will be there. Okay, so 17th question, answer is A. A is positive, A is a positive charge and B is a negative charge, and modulus of A greater than modulus of B. Why A is positive? The reason for A is positive means E lines, electric field lines are going out, Here what is the reason? Is B is negative means electric field lines are coming into, okay, it is coming into that point. That's what it is. Negative, other one is positive. Mode A greater than mode B. What is the reason for these statements? Because number of field lines, write down, number of field lines at A greater than number of field lines at B. Number of field lines at A greater than number of field lines at B. That's what option A is coming for the 17th question. Okay. Let's move to the next one. Hope you understood. 17th question. 17th is over. Move to 18th question. Point charges plus 4q and minus q are plus 4q minus q plus 4q are kept on x-axis at x is equal to 0 and x is equal to a and x is equal to 2a respectively. I'll take my another pen. Okay, x is equal to 0, x is equal to a, and x is equal to 2a respectively. So which means that what? This is an x-axis. This is an x-axis. So at x is equal to 0, at x is equal to a, and at x is equal to 2a, charges are placed. What are the charges? Here we have plus 4q. Here we have plus q. Here we have again plus 4q. No, here it is not plus, here it is minus is given. So 4 charges are placed at x is equal to a and x is equal to 2a and 0 respectively. Question is talking about, if you see the options, question is talking about equilibrium. Okay, we have learned about two types of equilibrium when we are talking about the torque. Okay, stable equilibrium and unstable equilibrium. Hope you remember this one. Stable means what? If you are giving any disturbance to that charges to the system means here charges. If you are giving any disturbance to that charges or the system, it will always come back to the original positions. It is something like a rubber band. If you are just pulling it or pushing it, and if you release it, it will always come back to the original position. So rubber band is the best example for a stable equilibrium. Another one, unstable equilibrium. If you make some changes to that system, for example, it will not retain or it will not come back to the original system. For example, if you have a plastic rod, just a plastic rod, you heated it up and you stretched it out, then that's all. Once you release it, it will never come back to the original position. It will be in a stretched format. So plastic, if you are extending, that's a best example of an unstable equilibrium, and a rubber band as a best example for a stable equilibrium. So here we have to discuss it. Okay, so plus 4q minus q and plus 4q are kept on x-axis at equal distances. Only minus q in stable equilibrium, none of the charges in equilibrium, all the charges are in stable equilibrium, and all the charges are in stable equilibrium. So always there are two terms will be here. When this kind of question will be coming, there are two terms will be there. One, from the question we can retrieve or we can find out whether it is stable or unstable. That is one decision. Another decision whether it is equilibrium or not equilibrium. Equilibrium means total force acting on a body is equal to 0. Okay, body is equal to 0 means left side ഒരു force, അതേ force, same force towards right side. Same case will be there for any other charges. So there are total force acting on the system is 0, then we can say body is in equilibrium. So first here our aim is to find out whether the body is in equilibrium or not. If you find out its equilibrium, then the next question will come whether it is stable or unstable. That we will analyze it and see. Okay, first we will find out force on this charge. Force on this charge. So force at x will be equal to 0 charge. Okay, so there are two forces because of this and because of this. Two forces will be here. So these two forces are what kind of force? Attractive force, right? Attractive force. So at x is equal to 0 point I am marking, at x is equal to 0 is this point, this force will be here. This 4q will attract towards minus q with a force like this, attractive force. 1 by 4 pi epsilon 0 q1 q2 by r square. So k is written k into 4q square by a square. And this plus 4q and this minus 4q will attract or repel? Repel. So one force will be there in these directions. So k into 16q square, q1 q2 divided by a square. What is the distance between them? 2a. So it becomes 4a square. If you simplify this, k into 4q square by a square. Now if you see at x is equal to 0 point, the left hand force is equal to right hand force, which means that what? Two forces which are acting in opposite direction, both are same magnitude. So I am asking a question whether it is equilibrium or not. You are right, this is equilibrium because equal magnitude forces are acting in opposite direction. So this is in equilibrium state. Okay, this is an equilibrium state. The same format you have to use it while you are finding for other force also. Other forces means what? X is equal to a and x is equal to 2a. We'll see at x is equal to a position. X is equal to a minus q. For towards plus q it will attract. So one force will be there, k into 4q square by a square. Towards left side it will attract. Correct. This will move towards left side because it is positive charge. So this will move like this one. What is the charge of this one? K into 4q square by a square. So two forces are equal. Yes, here also left side force will be equal to right side force. Two forces are equal. Body is in what state? Equilibrium state. So this is in equilibrium. We'll see the next one, the last plus 4q. This is located at x is equal to 2a distance. And this 4q and this minus 4q will attract. This 4q will move towards negative charge. What is the force? K into 4q square divided by 2a minus a. Distance is a square. Don't worry why I am not taking minus. Here 4q, okay, here 4q into q. Okay, somebody of you might think, sir, it is 4q into minus q. So minus 4q square will come. You may think like that. What it's indicate means minus sign indicate force is left side, or force is the direction of towards this negative charge, because negative charge will, what will happen? It's always attract. Okay, always electric field lines are always towards that. Positive means always away from that. So whenever it is taking in that direction, the electric field lines are towards that. So this indicate the electric field lines are coming into that. So this negative sign, okay, you can write this formula like this. For example, K into 4q square by a square in this direction. Here if you put minus. K into 4q into q, 4q into minus q. So 4q square towards right side. If you remove that minus, then the directions will be changing as per vector rule. If you are changing the direction, minus become plus. So I changed the direction. I changed the direction because here it is saying direction is towards minus q, attractive force. That's what I am not mentioning the minus here. Do not confuse. Next, plus 4q with the plus 4q. What it will do? It will this 4q will attract towards plus 4q. No, it will repel, right? It will repel with a force. How much is force? K into q1 q2 by r square. So 4q into 4q. Again 16q square divided by distance from here to here 2a. So it becomes 4a square. If you simplify this, k into 4q square by 2a square will come. So not 2a square, just 4q. So this left hand side force will be equal to right hand side. 16 and 4 get cancelled, so it becomes 4q square by a square will come. Left hand side is equal to right hand side. So this body is also in what state? This is also in equilibrium. This is also in equilibrium. This is also in equilibrium. So all the charges are in equilibrium. Only minus q is in stable equilibrium, going out. It is not a correct answer. None of the charges are in equilibrium. Pakka wrong answer. Third one, all the charges are in equilibrium. Stable, unstable equilibrium. Fourth one, all the charges are in stable equilibrium. We know. Now we know all the charges are in equilibrium. Now what we need to decide? Our next ultimate aim is to decide whether it is a stable equilibrium or it is an unstable equilibrium. That is the first intention. That's the first aim of a stable or unstable. Stable means what? As I told before, if you are giving any disturbance like a rubber band, it will come back to the original positions. Okay. Now, if you give any disturbance, means this plus 4q, instead of placing here, if you placed here, will be here. Along this plus 4q. You placed will be here. So what will happen? Now the structure is like this, right? There is a force, there is a force. So whole system is completely going to an unstable state. Unstable state means there are no driving, listen my words, there are no driving force to make the plus 4q to come to this original position. Anybody is pushing, hey, plus 4q, please go to x is equal to 0 position. Anybody is pushing? Nobody is pushing. If nobody is pushing plus 4q to go back to the x is equal to 0 position, which means there are no driving force are available to take it back to the original position. If I change it plus 4q to here, if I change it minus 4q to here, somebody will be pulling from top side and say, hey, go to x is equal to a. Somebody is pulling? Nobody will pull. It will go there way, it will go there. So, which means that what kind of equilibrium? This is an example of an unstable equilibrium. Once it is changed its position from here to here, from here to here, or from here to here, nobody else will help. This charge will come back to the original position. Nobody is available there to help you. If some force will be acting like this, then if I place it will be here, what will happen? It will come and it will retain will be here. So there is no driving force to keep it into the original position. That's what this is an example of an unstable equilibrium. So answer to this question is 18th answer is option C. There is no driving force to keep it back. So this is an best example for an unstable system. This is an unstable system. Why it is unstable system? We will write no driving force is available to keep the charges back to the original position, when it moves from its initial position. Whenever it moves from initial position, there is no driving force are available to keep it back to the original position. There is no driving force. Unless there is no driving force means it cannot come back to the original states. So it's like a plastic system. Plastic system means unstable system. So answer is option C. It's equilibrium and unstable. So let's move to the next question. Question number 19th one. Again, the question number 19 and the previous question number 17 is similar. It's a diagram based question. If you see the diagram, figure shows the sum of the electric field lines corresponding to an electric field. Figure suggested as that. If you see the number of electric field line at the point number A and at the point number C, both are same electric field lines, which means that what? Same electric field strength will be there. But in case of C, there is a relaxed electric field lines at the point A and B, as per the diagram, like this, right? As per the diagram, at the point A and B, this is the point A and this is the point B. So at the A and B, it's very congested. So which means electric field at the point A will be equal to electric field at the point number B, and definitely this is greater than electric point number at number C. So this is C is given in the question, right? This is C and this is B. So EA will be equal to EC, both are equal, and this is greater than that of EB. So answer is matches with your option number C, because both are same intensity. Same intensity means same charge, same field. And B side, it is a little bit relaxed. So A and C will be the same, and which is greater than that of the point B. So answer is option C is the right answer for 19th question. Okay, 20th question. We'll move to 20th question. 20th question: for distance away from the center of the dipole, change in magnitude of electric field with the change in distance from the center of the dipole is, okay, 0. Same in equatorial plane as well as in axis of a dipole. More in case of equatorial plane of dipole as compared to axis. More in case of axis of a dipole as compared to that of equatorial plane. Listen one point. Electric field intensity at the axis of a dipole. We have learned electric field intensity at the axis of a dipole, K into 2P divided by x cube. Electric field intensity at the equatorial position of a dipole, Kp divided by x cube. Okay, so electric field intensity at the axis of a dipole is K into 2P by x cube, and electric field intensity at the equatorial position of a dipole is Kp by x cube. Which one is higher will be here? Electric field intensity at the axis is higher and electric field at the equatorial is lesser comparable to axis. But what is the question? For a distance far away from the center of the dipole, change in magnitude of electric field. Change in magnitude means you have to differentiate this one. That is called change in. Change in magnitude means dE by dx. If you are differentiating this one, what you will get? Here K into 2P will be that's constant. If you are differentiating x, so minus 3 into x power, this minus 3, x power minus 4 will come. Okay, now if you differentiating this one, what will come? Kp into minus 3 into x power minus 4. Okay, x raised to minus 3 in the differentiation, x raised to 3 will be here. If you take in the numerator, it become x power minus 3. So x power minus 3 is equal to x power n. X power n is nx raised to n minus 1. So here nx raised to n minus 1 means minus 3 raised to minus 3 minus 1. That's what I am writing, minus 3x power 4 minus 3x power 4. So even if you are taking the change also, this is a higher. So electric field at the axis is greater than at the equator. We know already the equatorial position is lesser than that of axial position, but if you take the difference also, if you are taking the difference also, already this is higher. If you take the difference, the change means in the question it is means to be change in magnitude of electric field, which means differentiations with respect to distance. This is still it is higher. So electric field at the axis of a dipole is greater than electric field at the equatorial position when we are taking change in magnitude, and already magnitude wise also itself it is higher. So change wise also it is higher. So what is the option? More in case of axis of a dipole as compared to that of equatorial plane of the dipole. So answer is coming as option D is the right answer for this question number 20th. Okay. So let's move to the next question. Question number 21. Question number 21. Okay. Two charge Q and minus 3Q are placed fixed on an x-axis separated by a distance d. Where should be the third charge 2Q should be placed such that it will experience a net force? To answer this question in a very fast way, you have to watch my previous videos. Else also you can answer it, but it's very time consuming task. How many charges will be here? Two charges will be here. Hope you remember my sessions. If you have two charges plus Q and minus 3Q, these two charges are separated by a distance of d. These are equal charges or opposite charges. I am not asking about the magnitude wise. Magnitude wise, this is 1Q, this is minus 3Q. Sign wise, opposite or equal? It is opposite, right? If sign wise it is opposite, then the question is, where should be the third charge placed so that it will not experience any force? It will not experience any force means the charges is in equilibrium. Where should the third charge will place? What is the value of the third charge? Charge Q, capital Q, the charge two charges plus Q separated by distance of x square. Where should be the third charge will be placed to 2Q? Third charge 2Q has to place. So there are three positions. Number one, either I can place left side, or I can place in between these two, or I can place towards right side. What will be comes as an answer for this? Okay, I can directly say answer is left side, towards left side. It should not be somewhere in between the two charges and somewhere towards right. This I already mentioned this point while I am taking the theory. The point here is like, if it is a similar charges means positive or negative, then also, or if it is a different charges also, different magnitude also, then the next charge which is coming to the system, here 2Q is coming, that charge has to be placed nearer to the and left of the. If it is a opposite charges, then the small charge has to be placed left of the less magnitude charge. Less of the less magnitude. So this is a less magnitude charge Q comparable to 3Q. Magnitude means this is 3Q, then this is Q. So the less charge has to be placed left to that, which means 2Q has to be placed somewhere here at a distance of x meter away. That is the intention. It should not be at the right side, it should not be at the middle side. I discussed this while I am taking about the theory sessions, right? Whenever two charges will be here, if I am placing a third charge, then the whole system of charges are in equilibrium, which means the third charge should be placed nearer to the and left of the lowest charge. So here Q is the lowest charge. If you have not remembering, please refer your notebook. This we have already discussed, and we have written a shortcut formula for x. If it is opposite charges, we have written some formula, right? Q low whole divided by Q high minus root of Q low into the total distance d. This is a formula we have learnt. Okay, what is the Q low? Q low means this charge Q. So root Q whole divided by root of, how much will come? Q high charge 3Q minus root of Q. If it is same charge, I already discussed that formula also while I am taking theory. If it is same charge, it will comes as plus. You can refer your notebook. It will be there. This sign will be comes as plus if two charges are positive sign. If two charges are opposite sign, then this will becomes as negative. Now Q will cancel. So 1 divided by root 3 minus 1. 1 divided by root 3. Root 3 means 1.73. So 0.73. 1 divided by 1.73 minus 1. This will becomes as 1.42, approximately 1.42 times of what is there extra. D will be here. D will be here. D will be here. 1.42 times of D is the right answer for this question with the shortcut method. But if you look into the option, it is given in some terms of another factors, right? Doesn't matter, we can compare, we can solve the 4 option and we'll see which one is matches with this option. First one, if you see option A, D minus root 3. Okay, so D, if you take an outside, 1 minus root 3 will come. 1 minus root 3 means 0.73. 0.73 divided by 2, how much will come? It's less than 0.73 divided by 2 means 0.35 approximately. So option A is not the right answer. Option B, 1 plus root 3 whole into D. Okay, so 1 plus root 3 means what? 1 plus 1.73, which means 2.735 something will come. 2.73 divided by 2, which is equal to 1.4. Okay, almost equal to 2.8. So which is closer to this answer, 1.42. You will get exactly the figure. If you are taking root 3 means 1.735 something like that, right? So 1 plus 1.73 divided by 2 in option B is given D plus root 3 times of D divided by 2, which means 2.735 or something like that, into multiplied with the D whole divided by 2. If you solve this one, you will get it as 1.4 will be here also. So what is the answer for this question? Option number B is the right answer for this question. Okay. 1.73b. So where to place the charges? That point you always has to remember, whether it is towards left or between the charges or towards the right side. It is always towards the left side of the minimum charges. So this is a minimum charge Q, and this is minus 3Q is the highest charge. So the third charge is in equilibrium position, and that has to be placed nearer to the lowest charge. Please refer the class notes or try to watch the video where I am talking about this third charge, where has to place, whether it is right side, whether it is left side, where it is coming, and this set of formula for if it is opposite charges, this is a formula. If it is similar charges, here plus will come. This is already discussed. Okay. So we'll move to question number 22. Okay. Okay. You need all this shortcut formula, so then only it is easy for you to answer this part. Okay. So 22. Let's move to question number 22. What is question number 22 specifying? A charge Q is placed at each of the corners of an square. Charge Q is placed at each of the other corners. So let's consider a square. Here capital Q, here capital Q, here small q are placed. Okay. If the net electric force on Q is 0, suppose I am taking this Q, the net electric force, so F net will be equal to 0. If such conditions are coming, what is the value of Q divided by Q is how much? That is a question to us. Next, we know this length is, if I am considering as L. Okay, what is the force? This Q and Q will repel with the force. We'll find this force. Okay, this I am giving as F force. And if suppose if you are assuming small q and this small q are positive quantity, what will happen? Small q are positive quantity means this will repel like this and this will also repel like this, and the resultant force of these two what will act like this Fr. If two forces are acting like this will never come to an equilibrium state. Why? Already one force will be there F, another force will be there Fr, both forces will get added up and will get the total force. So if here some total forces are exist, which means it is not in equilibrium state. So what will happen? This charge should not be, we are assuming this, we are not assuming, it is mandatory that it is a negative charge. If it is a negative charge, instead of going this repulsive force, an attractive force will be here like this. Instead of going this repulsive force, this Q will attract. So because of these two, we will get a resultant force will be like this. In this case, there is a chance to have Fr equal to F, then the two bodies are in equilibrium state. That's the condition. Okay, so which means Fr equal to F. This condition should come. Both forces are equal in magnitude and opposite direction. It should not be Fr in the same direction of F. If it is come like that, then there are no chances that the forces should be in the system in equilibrium, because two forces are acting in the same direction. What is Fr? Fr means resultant of these two. Okay, these two forces will be there, and here as one force will be here. This I am giving as for example small letter f, this I am giving as small letter f. So small letter f will be equal to k into q divided by L square. Okay, so this Fr will be equal to, we have two vectors are there, right? One vector and another vector like this. So what is the resultant formula? A square plus b square plus 2ab cos theta. So what is coming? Root of f square plus 2f square of cos of 90. Angle between the two vector is 90. So what will come? Answer is root 2 times of f, which means that root 2 times of f means what? K into q divided by L square is coming. Okay, so we got Fr, and f value also we need to find out. F value means force between the capital Q and this Q. So Fr means root 2 times K into capital Q divided by L squared, which is equal to, what is this F? F means the repulsive force between capital Q and Q. So K Q square divided by, what is the distance from here to here? What is it? This is L, this is L. So we'll apply the Pythagoras theorem. L square plus L square, base plus height, which will become what? Root 2L. So this is root 2 times of L the whole square. So K cancel, capital Q cancel, K cancel, capital Q cancel. So we are simplifying further. What is there? L square cancel. Root 2 into Q will be there on the left side. And the right side, what is there? Capital Q will be here, because one Q is get cancels, divided by, what will be here? Here root 2 L square. L square is cancelled. Root 2 square means 2 will be there, right? 2 will be here. So Q will be here and 2 will be there. So what is the question? Capital Q divided by small q, which is equal to 2 times of root 2. So answer is 2 times of root 2. Okay, here if you see capital Q divided by small q divided by 2 root 2. Here I told Q is not a positive charge. Q is what charge? Negative charge. Okay, so Q is a negative charge. So actually we are getting the final answer if this Q should be a negative charge. Then if the Q should be a negative charge only, we are getting this one. So which means Q divided by minus Q is actually we are getting 2 root 2, or we can say Q divided by plus Q. If you are taking minus 2 into root 2. Okay, here Q should not be a positive charge. Q definitely should be a negative charge. Then only this force and this force all together Fr will come. Fr will be equal to this F will come. If that two forces are acting in opposite direction, both has to be cancel each other. Then only this will exist. For this one, this should be a negative charge. So we have a resultant force on the left side and right side, and this Q should be a negative charge. That's what we have written. Q divided by minus Q we have written, and Q divided by minus Q is actually we are getting 2 root 2, and Q by Q will be equal to plus root 2. So hope this is clear to you. Okay, Q divided by minus Q is equal to 2 root 2, and Q divided by plus Q is equal to minus 2 times of root 2. This Q should be negative and this Q should also will be negative. Why it is negative? You can write here, to have equilibrium state. to have equilibrium state. To have equilibrium state. To have equilibrium state, definitely this should be a negative charge. If it is positive, as I told before, this Q and Q will repel, this Q and Q will repel, resultant force will come. So two forces are acting in the same direction means we'll do a vector additions, we will never get a equilibrium state, or total force will be equal to 0 is not possible to get for this one. Okay, hope you understand till question number 22.